Hi everyone, welcome back. We are in the Starknet bootcamp. So this time we're going to talk about Starknet.rs and Dojo. This is some of the tools that you can find in Starknet. Remember, we have this GitHub repo where you can find the info about the lessons. Also, this website from OpenBuild. So yeah, this time we're gonna check the Starnet book. And remember before we talked about what do we need to install. We talk about Starly, Scarp, Katana. We deploy it on testnet and Katana. So now we're gonna talk about Starly. What's Starly? So first you also can check here the website from Starly. Like they said, Starly is a command line. It's a command line tool for interacting with Starnet. So this is built on top of Starnet.rs. So yeah, it's gonna be really nice. Starnet.rs. We can find the GitHub repo here. So this is a library written on Rust, so you can connect to the blockchain to Starnet using Rust. So this is all the feature. You can find it here. So in top of Stark.rs, we have Starling, that is their CLI command line tool. So I'm gonna check something with Starling and Starnet.rs. So here, so the idea is to use Starling. Remember before we used to declare and deploy some smart contracts. But now we're gonna check more options. What else we can do here? So like they mentioned, Starling is a command line interface tool designed by Starling for Starling interaction. So yeah, it uses Starling.rs to simplify this kind of interaction. So we can query and execute transactions on Starnet. So first we're gonna check some commands and then we're gonna create some bash script using Starling to query on Starnet. So yeah, this is an example. So you can create your own bash script to interact with Starnet, but this is gonna be the very beginning. So for this, we have to check if you have installed Starly or not before. So we're gonna have like this. Maybe like this is okay. So here we just gonna check if we have Starly. In my case, I have. This is one of the latest. Cool. This is one of the latest version of Starly, so it's fine. So I have the Starly here. So we continue with this. So they also mentioned about the providers. There are many providers. I mean RPC providers. In order to connect with the blockchain, we need these providers. They're gonna provide like a RPC URL to connect our program with the blockchain. Some of them they are in Future Alchemy. I think we also have Nethermind, so you can check there and find the RPC URL. Another way how to how to connect is with Katana, is for local .NET, and you can also set up your own node. Yes, if some of you are interested in this, you can check this option. In our case, we're gonna use these two samples first with Alchemy and then with Katana. But first with Katana, let's check here. Interact with Katana. For this, we have to run Katana. Remember, you have to install Katana first and then run it. Katana is okay, so Katana is running now. So after that, you can see here Katana. Let's put it here. Katana here, and this is our command line. Then, so for this, we can use Starly to retrieve the chain ID. So it depends, In this example, we want to get the chain ID using Starly. So how can we get it? So we're gonna do like this, copy this, Starly, chain ID, we have to pass the RPC URL. In this case, we have the RPC, and we are gonna pass, this is the same RPC that Katana provides. So we're gonna do the same here. Chain ID, we have to pass which RPC. It's gonna be this one with the local host. And then, great. So this is the chain ID for Katana. And you can see here, this is the log about Katana, something happened here. So yeah, they got this method, chain ID. So it's the same one. We can also check, we can use Starly to check what is the latest block number on Katana. So we can do this. We just replace here. We have to put block number, and then we have to pass this argument, RPC, and the URL. So we can have a Starly block number, and then we have to pass this argument. And then, yeah, we get 0 because we didn't do anything yet here. So that's why Katana is still on 0. So yeah, that's it. Yeah, they say the block number is 0 because we didn't declare or deploy something on Katana yet. So that's why. So yeah, in order to get this, maybe you want to check the block number is different than 0. So we can declare something here, and then we can check the block number again. So on this time, let's see if we can find some example here. Remember our voting contract? Let's go there. Let's check there. We have compiled this voting contract. Yeah, this is our voting contract. Remember for last time we used Starnet Foundry. Yeah, this is our voting contract. So we have this target. Let's call it, oh yeah, voting contract. This one. Okay. So we can deploy this on testnet. So let's see. I'm sorry, we can deploy this on Katana and let's see how it goes. Yeah. So let's say we want to declare this. So we are here, we can run starting, declare, if we have to pass this contract class JSON file. So we have to go target, dep, and then we have to pass this there, both in contract class, yeah, dot JSON. And let's see how it goes. And then, yeah, we have to pass the RPC actually. We have to pass the RPC. We have to say we are using a Katana. So we have to pass this. Yeah. Let's try this. Currently, we have to pass the accounts. So since Katana is using the default Katana 0, let's try with this. Account Katana 0. Okay, great. We have declared it. So remember, uh, Katana is going to provide you all of these, pre-deployed wallet address. So here they are asking for this. You can try with some of them here, but they already have set up this like short name, Katana Zero. So you can use this Katana Zero is part on this from this example, from all of this example pre-funded. Yeah, this one. Yeah, prepaid contracts, pre-funded accounts. Yeah. This is the account that they are asking. Katana Zero is this one. So yeah, okay. So we get it, we declare it, and then you can see something happen here. They say block one, mine it with one transaction. So it means we're supposed to get one block number now. So let's retrieve again our previous code. Yeah, we're gonna check what is the latest block number now, and it's one. Why? Because we declare something on Katana. So if we continue doing some more operations like a deploy or invoke calls, so you're gonna see that the block number is gonna increase. Yeah, this is this. Yeah, same like here. So also they have this. If you have a string value pass, you can pass like this way, str, and just the string literal that you want to pass. In our case, we don't have a constructor. I mean, our constructor is not gonna receive anything like with a string. So we can skip this, but you can try at the moment. So this is gonna, you don't need to do this two Cairo string to get the hexadecimal format for your input. You just can put the string like this and it's gonna work. That's why it's kind of useful. And now we can try with testnet. So remember for testnet, we're gonna try to do something like this for testnet. We are done with Katana, so we can close this Katana, close terminal, yeah. We're gonna clear here. For testnet, we're gonna do the same. Here we have to pass the RPC URL for Starnet. It could be Alchemy, Fura, any of them. So we're gonna do like this. Starling block number, RPC. And then this time we don't have to run Katana, we have to close Katana, turn off, and then we have to pass the testnet RPC URL. In my case, I'm gonna use to check here. I'm just Alchemy. I need to get my one. So this is one of my APPs. Started early in my case. IP key. I have to show this one. So yeah, this one. So I have to pass like this. Starkly, block number, RPC, and I have to pass my URL. So yeah, we got this is the latest block number now on testnet. So you can see what using Go early. So at this time, this is the latest block number on Go early. Different than Katana yet. Katana is gonna start always with zero, the value, at least for now. But on this command, we're using testnet with Alchemy, so the block number is totally different. Yes, the latest one is. So yeah, in this example, they did it before was this number, but right now it has increased a lot. And yeah, you can also check it with the scan. What is the latest block number? Blocks you can see 91A 607 60688. So yeah, because we wait for a let's repeat again. Yeah, this is one block number from difference, but yeah, it's pretty the same. So yeah, we can check later and see how it goes. And yeah, so we're gonna try some like invoke commands. So for this example, let's say we want to transfer some ETH from our wallet to another wallet. Remember before in the examples we have two wallets, yeah? Wallets with Bravos and wallet with Argent X. So they say you can transfer it when you open your Bravos or your Argent wallet, but you can do the same only with Starly. It can be a lot easier. So what you need to do, they say you have to export, yeah? You need to export your Starnet account and your Starnet key store. So I'm gonna do this. I'm gonna transfer from my, let's say, Argent account to my Bravos account. So I'm gonna export this. Remember, before to do this, you have to set up your account and your key store on the local machine. I assume that you already did it because we showed how to do this on the previous lessons. So I'm gonna go direct to this. In my case, the name is a bit different. My account agent. Yeah, my account agent. Great. The second one, the key store. My key store agent. Right. So the sender is gonna be this my Argent account. So the sender is gonna be my Argent account. So who's gonna receive this like Ethereum of course Goerli it is gonna be the Argent account. So for that I have to pass on this command. So let's see how it goes. First, let me try to open this. I'm gonna show, yeah, I'm gonna open this here. I need to get my Bravos account. So yeah, this is my Bravos account. So I'm gonna paste it here. Okay, Starkly involved. I want to transfer transfer. I'm gonna paste. This is the target address. I'm gonna send it to this. How much? Since this is like U256 value, I can format like this U256, and then I'm gonna pass a bit more this amount of weight. So remember, I already set up my Argent account to send it to my Bravos account. So yeah, I also have to wait. I have to pass the RPC one. RPC is gonna be this one. Yeah. Four. Okay, great. So we got the transaction hash. So it means it's working. We can check this on the here on the Starknet scan. We're gonna paste this. Copy. Oh, it's here. You see, this is the sender address. So here, this is my like Argent account. Oh, is it here? Yeah, from my Argent account to my Bravos account. My Bravos account is this one. Yes, 00D. So yeah, I send this amount of it, go early it. So you can see it's yeah, pretty fast, pretty fast. Yeah, so fast. And that's it. So you can do this kind of transfer with Starby. So yeah, it's really useful. After that, we also have this sample. So the idea is, you have to know what are the commands for this, and then you have to create your own bash file to run into your local machine. So here we can find this example with Katana. let's clear it. We'll do it so quick. Here, for example, say this section provides a step-by-step instruction to create and run custom bash scripts for Starknet interaction. So yeah, we have to ensure Katana is running. So we have to open our Katana here. Katana, let's run Katana. Katana is running here. It's good. Then we have to create a file. They create like this touch. So remember here, create a file first and create examples. We have examples, yeah, we need examples. So here we're gonna create, right now it's empty. So we're gonna create this file. So let's see, yeah, we have this file. And then we have to edit this file. Yeah, we have to edit and we're gonna paste, we're gonna copy and paste this bash file, bash content, yeah, copy. So here you have to open this file. You can use like any text editor. Could be VS Code or could be any text editor that you have in your computer. Could be Bing, but now I'm going to use Nano. It's one text editor. You can use the same. Nano is still there. So I'm into the Nano terminal. So we're going to paste this. Control Shift D, paste it. Okay, I'm going to save it. Control S. Control X, I'm gonna exit. So yeah, that's it. Let's check if I have, let's check what is inside my script. So yeah, it's all of this. Okay, that's good. Now we can run the script like this, bash. And yeah, oh, you can see this is the log on Katana. And they say, yeah, we have connected to Katana. This is the chain ID of Katana. The latest block number is 0. And we did some required. Yeah, we asked for the balance of this account. And this account has 1,000 units. So that's what our script does. So let's have a look here. Yeah, this is how the bash works. So in this case, I have this chain. Basically, I'm just passing this command on this variable. So here I have Starly chain ID from this RPC, we saw it before, but now yeah, I'm gonna paste it here. I'm gonna print it here on this echo, it's like a print. That's why I got this echo, and then I got the answer there. What is the output from this command? The output is the chain ID number, and this is the chain ID number. After that, I input a second command to get the latest block number. I got the block and just print it here. The block number is 0. And then I pass the account. This is the account, one of the accounts here. This is the first account. Here, pass the account, and I'm going to ask the balance of this account on Katana because I passed the RPC. And they say the balance of the account is this one. This is 1,000. It's great. This is one example. Then we have another script with testnet. We're going to do the same. Touch, create a file. We have the script for testnet. It's good. We're going to paste this. Like I say, I'm going to use Nano to edit the test, but you can use anyone that you like. I test it. Okay, great. Now I'm going to run again. Oh, remember, and this time I have to input my testnet API URL. My testnet is, just check, wait, I can find it here somewhere. Oh yeah, it's this one. Okay, I got it. Bash script testnet, yeah. I'm gonna paste my URL, and also I have to input a transaction hash. For example, just one, we did this. This is the transaction hash. I copy, paste it here. Oh, and I get this, all of this output. So let's see what's going on. First, yeah, we read the URL from our testnet API URL, and then we connect it. We just ask for the chain ID of this. And the chain ID of this early testnet is this one, yeah, 0x53. Later, we ask for the block number, and the block number is 91. So it has increased from before. And then we ask for a transaction hash, and with Starly, we ask for the receipt details from this transaction. So we want to know the receipt details from this transaction. So that's why we pass the hash, transaction hash, and the RPC URL. We already got the RPC URL, so that's why we ask for the transaction hash here. I input this one, and after that, yeah, you can get all of these transaction, all of the details about the receipt of the transaction. Yeah, and you can check that. And yeah, that's it. That's it. So yeah, it's at the end. It's up to you how to use Starknet, how to create your own bash file or bash program to interact with the blockchain. So that's it for now. Yeah. After this, we're gonna talk about Dojo. Dojo is one of them a really cool tool on Starnet. Let's see how what can we do there. Okay. Let's see in a while. Okay. And now we're going to talk about Dojo. Maybe you heard about it before. Project that is becoming really famous on the Starnet ecosystem. So what is Dojo? Like they mentioned here, Dojo is a provable game engine and tool chain for building on-chain games and autonomous war. So it means like Dojo is like a framework on top of Starnet, Cairo, that is going to help you to build games that fully on-chain games. So it's going to provide some macros, some tools inside that is going to help you to develop your on-chain games. Cool. So they say rapidly build and deploy on-chain games and autonomous war with Dojo toolchain. So games are defined and governed by their smart contract, existing entirely on-chain and inheriting the unique affordableness of the blockchain. Possible extensible permissionless persist. And yeah, this is like a basic example. On top of that, in this case, we use Dojo contract. Remember, before we used Starnet contract, but on this time, we're going to use Dojo contract. We have our module import. We define in order to define the implementation of our interface, we use external PCO. And then here, yeah, for example, this self-word dispatcher is just from Dojo. You can use it on Dojo, not in Starnet. So remember this. I use it with Dojo. And this is the macro get and another macro set. So yeah, this is a basic example. We're gonna get deep into this. There is also some posts if you want to know more about what is on-chain gaming, global games. Yeah, you can have a great article in order to know more about it. For example, here we can check a bit more about Dojo architecture. Remember Katana, which is before. So actually, Katana has been built for the Dojo team. So also they have this tool, Tori server, that is gonna index your game, your war. It's gonna provide you some like a GraphQL schema, also some gRPC. It is gonna be really useful if you want to connect with the front end. And also these tools, RTC Stack, WebRTC, and also we have this Tori client. So remember from Katana to Tori, they communicate through JSON RPC. And from Tori to the client, like I said, they have GraphQL, gRPC, WebRTC. And yeah, they also have the optimistic execution, client-side program. And from here, you can connect. You have your entities ID components. And yeah, you can connect with any SDK. They provide all of the SDK, Ruby, JavaScript, Phaser. That's the idea. Also, we can show this. We have Ethereum. Yeah, from here. Yeah, that's it. We can continue. So we can check there. So we're gonna check the book a little bit. So here also, yeah, they explained what is Dojo, why Dojo. So remember, Dojo is like a game engine or like a framework that's gonna help you to develop your game. You can check more here on the documentation, yeah, on what is Dojo, like we saw before. We have remember everything is If it is on-chain, everything is going to be a smart contract. So this word contract is going to be our smart contract. It's going to be like the main smart contract on our game. And then we're going to have like a small smart contracts. They're going to be like our systems. And then we're going to have some components, but they are like modules in this case also. Modules components, they are the same. And yeah, Tori that is gonna connect with the SDKs with the front end. Yeah, you can check more about here. What is Tori? What is Katana? What is Soso? Also like the CLI, but basically to declare or deploy here. Yeah, and help you to create, build, test, deploy your words or your games. Katana, you already know. Tori, you can check later. It's gonna be useful with GraphQL API. You're gonna see. Then our ecosystem, zero knowledge, Starknet, blockchain. We can start. Yeah, so for this, we have to install Dojo. We're gonna start with example very soon. So what you have to do is you have to install Dojo, open your terminal, okay, install Dojo and then Dojo app. So we're gonna get the latest version of Dojo. Right now you can see at this moment is 0.4.1, but later on they're going to release new versions. So I will be aware about it. We're going to check. We can close this now. We can open again. We can see, for example, Katana or Tori, Tori version. So yeah, great. We have this latest version of Dojo. That's good. They also provide this manual installation. If you just want to build games, don't need this. It's more like for, I mean, developers that want to, improve or solve some issues with Dojo. You can play with this. But if you want to build games, don't need it. Yeah, this is also in order if you want to contribute to the core, to the Dojo code base, you have to follow these steps. If you know Rust, because on the here, this is the Dojo. This is the Dojo code base. This is the issues. So if you know Rust, you can contribute here with some issues, and then you can check this the code base. Here is mostly in Rust. So yeah, have a look there. Yeah, they offer the Discord, Twitter, even Telegram somewhere. You can check some projects there. You can check there. Now the architecture, like they mentioned, we have Word right here, for example. We have Word, they are gonna be the core, the smart contract. So if you're a player, you're gonna call a system. The system is like the actions here, the functions. It could be like a movement of your player, and then you connect with a word. So here, all of these, they're like a models or components or your data structure that you have. It could be your, for example, position X and Y. That could be your structure or model. If something happens here, we are going to release an event. So one event is going to be immediate, and Tor is going to catch this, and it's going to send it to the client or to the front end. So yeah, that's it. The word is like a central core. The models, you can check, we have events. They support all of these methods. Not too important now. And functions as contract methods. So if you have your smart contract methods, they're gonna be like the functions of your system. That's it. You can check more here. Like I said, models, data, your data structure. Model store structured data in your world. It's like a data structure. And you have to add this attribute in order to, you know, to make them know this is a model. For example, like I mentioned before, Dojo is built on top of Cairo. Some examples, like they say, imagine JavaScript and React. React is like a framework. Dojo is almost the same. So they have special attributes that only works on Dojo, like this one model. But we still can use Cairo. So we have the example of this model there. We're gonna check later more example, some commands like the get command on macro, get set, init, config, how to we can set up our project. The most important part is here we have to add a dependency here like this, similar to Starknet Foundry. Do you remember? So in this case, we're gonna add this Dojo like a dependency. We have to show the version. Also, events quite similar like a Starknet smart contract, authorization. Yeah, we can say we can check later more about. It's like who can interact with your smart contract. So yeah, in this case, you're gonna, like say, as discussed in the word chapter, autonomous word function as sovereign chain constitute the public chain. These words are also open to the public. This structure allows anyone to interface a word by deploying models of systems. So anyone can contact the word and deploy more model system. However, this openness also introduces security considerations, yeah, because you don't want to anybody exchange your game. In order to continue interacting with the model state within a system requires appropriate authorization for a model owner. So we are going to set up who can interact with our models. So every time I set is called in a system, the word checks if the system has authorization to update the model state. So this is really important. Really important. So every time I set is gonna, it's like a write something. You're gonna change the state of smart contract. If you call it set, so every time set is called in the system, the word checks if the system has authorization to update the model state or not. So for this, we have to set up. We're gonna choose. We have to say this system can update the model state. Only when the system possesses the necessary authorization, the set is executed. The following diagram illustrates the authorization. Yeah. Execute, caller, execute system, set. They're gonna check the authorization. No authorization is gonna throw error. Right, state component. So how do we provide authorization? This is like the way we're gonna authorize. Like this is how can modify the moves model. That's it. So this command will generate the right authorization for the spawn system to update the model, the moves model. Yeah, that's it. You also have metadata about your project, like this. And now we're gonna check this section. So we're gonna start with the coding part. This is the Hello Dojo. So we're gonna follow this tutorial in order to build Dojo. So great. So this session assuming that you already installed Dojo toolchain and are familiar with Cairo. Yeah, we just installed Dojo tool and we work with Cairo since a few weeks ago. So it's fine. Yeah, they talk about ECS, like entity component system. Yeah, it's like a framework, so like a architecture, like a style, how to develop your game. It's a design pattern for gaming. So in this context, systems shape the environments, logic, while components or models mirror the state of the world. Yeah, the logic is gonna be on the system, and the components is gonna contain the data structures. Yeah, talk about this. So first, to start, let's set up a run locally on your machine from an MTD directory. Execute this. So gonna open our terminal first. Here we are. We can set up like that. We're gonna follow this. So we're gonna create a empty directory. We're gonna call it Dojo Starter. Starter. We're gonna go into this. Dojo Starter. Starter. Okay. Now, once we have this, we can copy this as an init, and it's gonna create a template for us, so we can go from here. So in case I'm using Visual Studio Code, so here we go to here, and we can find all of these files, actions, lib, model, utils. Same like here, we're gonna say, yeah, we're gonna find this. This is all the folders that we have of structure of our game. Actions is going to contain the systems, the functions of the system, models or data, utils, some helper functions here. So the your project builds strongly resemble a typical Cairo projects. The primary difference is the inclusion of special attributes tags. Yes, it is like we mentioned before. You need to define your data models. Yeah. In this context, we will refer to these models as components. And yeah, so we can use models, components. We are crafting the ECS, remember, Entity Component System. We will adhere to specific terminology system, Entity Component System. So yeah, let's check the models here. Okay, let's check the models. So let's first check these moves. So we will have a model, call it move. On this move, we're going to store the player. So the player could be like a player ID. So the ID will be like a contract address. And then remaining is like the remaining steps or moves that it has. You have 10 remaining moves or 20. And then the last directions. So it's going to move here, like you see, the direction is like a known type. So in no time, it can move to left, right, up, down, or by default it's no. And then can move to any of them of these directions. And then we have this like a position model. Position model is gonna contain the player address as well as a key. So this key is important because this is gonna help us to retrieve the data from this structure. So you can see it's also like a primary key. It could be, if you know SQL or databases, imagine this key like a primary key in order to retrieve data from your site. Also this position. And then we have this back2 traits because what we have this back2 stroke. So here it's like a helper stroke. In this case, we have X and Y. So it's gonna help us to move, X for this side and Y for this side. So yeah, like a map. After that, we can implement some trait for this back in case it's zero or is equal. For example, function is zero. What's gonna we're gonna check if X and Y they are the same. So it will return true, otherwise false. And if it's equal, so we have to pass another here. Yeah, we have to pass another vector. We're gonna check it if both fields are same. We have this test. We're gonna check it later. The test. So that's what we have in our models. So like I mentioned, all of this. Yeah, this is like a special attribute for Cairo, especially this small model. Yeah, we must include this model. Our moves model houses a player field. Yeah. At the same time, we have the key attribute. It's to enforce value that this model is indexed by the player field. Yeah, this is how can we index the player? How can we retrieve this data? So yeah, it's like they say, it's gonna help you to query. Essentially, it implies that you can query this model using the player field. Why? Because we have this key annotation, key attribute. So yeah, position as well. And then now we can check the actions file. Here we have the action file. We define the interface, similar like for our Starnet, because the Starnet interface is going to be the same. But in this case, we define two functions, spawn and move. Spawn is really common on gaming. It's like a init, like a, you can think it also like a your constructor or init function that happens at the very beginning of the game, and then you can add more functions like a move. Somebody is going to move here. After that, we're going to implement these interfaces where here inside is we're going to define our smart contract. In this case, it's going to be Dojo contract. We defined our mode actions, like a module actions. We import this from Starnet, fine, but also we import this from Dojo examples. This Dojo example is our project name actually, Dojo examples. So that's why we can import this position, models, mode, direction, deck2 that we saw just before, and also some util function like this one. We're gonna check it later. We also import the field interfaces from above. Okay, now we have this event. We have to create an event, move it. So how is it? We're gonna emit an event move it. If the player did any kind of move, we have to emit event showing the player contract address and which direction they did go. Now we have to implement the interfaces from here. In this case, we implement the spawn function for this one. We're gonna need this variable word dispatcher. That's why we have to access to this. How did we get the dispatcher? Self, word dispatcher, and read. You can see it's even more simple. Yeah. Before you use your Cairo Starknet smart contracts, you have to build a lot of helper functions in order to get the word dispatcher. But here, just with one piece of line, one piece of code, one line of code, you can get the word dispatcher. So it's gonna be cool. Then we get the caller address. It's gonna be the player. Yeah. Now we can retrieve what is the current position of the word. So we can apply this get macro, get command. We have to pass, remember for position 10. If we want to retrieve the position, we have to pass a key. The key is a player contract address. So that's why here we pass player contract address. Yeah. So this is gonna be a pattern. So from the word, I want to retrieve position and I have to pass the key. The key is the player. So according to this key, we are gonna search it. I'm gonna give us this struct. We get this struct here, position. Something is wrong with the plugin. That's why it looks like there is an error, but actually there is not error. So don't care about these red lines for now. Yeah, just let's continue. Yeah, we have been here, and then we have these moves. If we want to retrieve the player's moves data, same. In this case, moves also they require the player as a player contract address like E. So we pass here, great. And then if we're gonna apply set, so set what's it gonna do? It's gonna update the word state with new data. Set player moves to 10. Okay, check here. Moves. So in this case, we're gonna set these two models. We have to pass the model here. The first model is this moves. For moves, for example, we have to add one more. We're gonna set moves is gonna have the player contract address, okay? Remaining, we're gonna set up the remaining is 100 units. Last direction, because there is not last direction, we are on the spawn. We are at the beginning of the game. So the direction is known. In this case, for position, we have to set up player number first position here. We have to pass a player contact address, and then we have to pass this beg2 data structure. Beg2 has x and y. We're going to define beg2, set up x like a 10 and y like a 10. Okay, so they are going to be the init values. Every time we call a spawn, we're going to set up like this. Next, we're going to implement our move function. So similar to just before. And we're going to call the word dispatcher player the player. And then in this case, we can get, yeah, for example, this time get, we can retrieve both models, position models and the moves model, since both of them, they require for player, like a key. So there is not a problem for that. And now we can get both of these position and moves model. So if we make one movement, so our counter, our number of moves is gonna reduce by one. That's why they say here remaining is the last value minus one. For last direction, we're gonna get this direction. So from when you call the move, you have to pass the direction. Where do you want to go? And we're gonna set up this here. Remember, moves is like mutable. It's a mutable variable, so we can update this value. So the remaining is minus one, and the last direction is that direction we input from our move function. And then we can check the next position. Yeah, then we have this like a next position. This is like they say calculate the player next position based on provided direction. So let's check this next position. They are in utils. So we're gonna open here utils. Let's see it. Yeah, next position. So for next position, we pass the position data structure that we get. So this is the current position. But remember, this is a mutable variable. And then we got the direction. Where do we want to go? So in this case, if you go to left, the position is gonna change the x value minus one. because imagine you have your like a mapping there, x and y function. So if you go to left, it's gonna be negative. If you go to right, it's gonna be positive. Right, it's plus one. If you go up, it's gonna be y plus one. Oh no, this is yeah. And down, y plus one. From gaming, they start from here, yeah. X, Y, and then go down. Yeah, that's the logic. You can implement this according to your own case. So no problem on that. We got this next position set up. So actually, this next position is going to update this data structure. Yeah. So it's going to be next. So we're going to return the position updated. We're going to return the position we pass here. We'll return it. After that, we can check on this set. We're going to set our word with moves. Moves has changed. Yeah, it has changed like this. And position has changed. Yeah, now it's next position. It's changed. So we're gonna update the word state with removes data and position. Yeah. And then we're gonna emit event. Emit event with the player address and the last direction. Right? And then we have the test. You can check test then. Let's go back to the here. Yeah, they explain the event, span function, move function. They explain we have this get command, set command. That's it. So now we can run it locally. This is the funny part of this. Okay, let's let's interact with this. Oh yeah, before that, remember, actually Cairo, I mean Dojo, this latest version, they use Cairo 2.4 version. So make sure that you have the star in this version because if you install Scar, you have Cairo 2.4. Same like here. Make sure you update it to the latest Scar version in order to compile this example. Like I said, yeah, we have to add the dependency and the version of this dependency. And yeah, that's it. After that, we can patcher utils. Yeah, we have to run Soso build, yeah. I think Soso is, you can see like a scarp. It's gonna be our CLI. Before we did, if it is a Starknet Dojo Cairo smart contract, it's gonna be, remember, we used to do scarp build, but we are now in the Dojo context, so it's gonna be Soso build. Okay, now, yeah, we got this target file with all of these files. We don't need to check it right now. So we can do like this. Okay, okay, much better. So, oh yeah, yeah. But now we have to open a lot of terminals because we have to deploy and then open the local host. So let's move to here. We are in Dojo Starter. Remember, clear. In my case, I'm gonna do this. Okay, great. I'm gonna open. Yeah, it's gonna help me a lot because remember we have to do also build. We already did it. I'm gonna do it again. And then they say we have to use Katana, yeah? So Katana disable free. Oh, sorry, my typo. Okay, Katana is working. It is also build. What else? Yeah, Katana disable. So build, yeah, is gonna compile our game. In this case, everything is fine, so it has no errors. So after that, we are gonna do also migrate. What's gonna do this? This will deploy the artifact to Katana. You should see some. So we are gonna inside here. We are gonna declare and deploy everything that we need in our for our game. So yeah, you can just here. It's also migrate, and then you can give it a name to your project here. But in my case, I'm just gonna keep it like that. Or let's try to get my name. Like starter, right? So our warning is going to be a starter. This is my migration account, like my account that I'm using to deploy this. Remember this account is this one there. You can check. Here is the same. It's a pre-funded account. So our warning is going to be starter. Just keep it like this. They call the executor, the basic contract, and this is important. This is our word address. So this is our work address. We're gonna use it later, but also we have to we get the class hash for our moves models, for our position models, and for our systems we get a contract address. Remember our system is the actions. We call it actions, and this is this contract. So we're gonna use actually both of these two contracts, our work contracts and your system. In this case, I'm just have one system, but you can have many of them. Same for models, you can have many of them, but we're gonna use these two contracts and then you're done. And then you can see here a lot has happened here on Katana. A lot has happened. At least 10 blocks have been mined. Good. Yeah, you have your war address. In our case, it's a bit different because it depends your version. They say, okay, check you have this version. In this case, yeah, they say 3.14, but should be 0.4 in our case, 0.4.1. After that, yeah, we're gonna do indexing. Remember, we talked a lot about Tori, so we're gonna run, as I say, open a new terminal and input a simple command to include your own word address. We have to call Tori word and pass the word address. For this example, is this word address, and like that. But for our example, for our case, we have to input our own word address. Tori, okay, just follow them. For example, here we can use, let's say, Tori word, our word address. This is our word address. Great. Now they expose these to endpoints, especially for the GraphQL. We're going to follow this some example here. So the GraphQL is going to help us to retrieve some data that we need. Maybe some of you have played with this before. That's going to be great. Otherwise, it's not a problem. You can check here how to work with this. So it's going to show you this website, like browser, localhost, and we can query some, we can make some query, and then we can get some data. Let's see, for example, yeah, we just run this or running the command mentioned above, start a Tori server, yeah, the Tori server is working. The server on your local machine, this server uses SQLite as its database. Yeah, there is also a way how to use make persistent, yeah, your Tori with SQLite. You can check the documentation here. I mean, on the book, yeah, you can check there. And this is accessible with this. Okay, we are on this. Tori will automatically organize your data into tables, making it easy for you to perform queries using SQL. When you run the command, you will see something like this. Yeah, actually we did it. Yeah. You can observe that our moves and position models have been successfully registered. Let's see here. You can check here. Yeah, registered model moves, registered model position. Yeah, that's it. Why? Because we did it migrate, yeah? When we did that migrate, it has registered the moves and the position model. That's why they index it here. Yeah, have been registered. And next, let's use the GraphQL ID to retrieve data from models. So we can input this query. So actually, yeah, we're gonna get some data about the models. In this case, we're going to search for models. We have to put the ID. The ID is going to be moves. We want to search about moves. Okay, great. So this is the ID, the name. We got the class hash, the session hash, and when has been created just now, a few minutes ago. So yeah, you can see if you get this data, it means your Tori and GraphQL is working. So that's good. Yeah, you can want to get something like this. And yeah, we can use GraphQL to query some values, or we can subscribe to some events and get the data. For example, in this case, we're going to subscribe is something happened to our entity, any entity, if any entity has been updated. So we're going to be listening to this. Okay, let's copy it here. Open this, can clean it like this. Okay, now we have this subscription and we're going to subscribe in case any entity has been updated. So this time, this Subscription is listening if something happens on our game. Okay, let's move to the here. So now what we're gonna do, we're gonna use our actions contract address. So we have to use our action contract address to start to create entities. So first we have the models, and then because it's the first time we're gonna execute, so we're gonna create entities in our local machine. How do we accomplish this? We're gonna put so execute your actions contract address spawn. Remember spawn? We're gonna call this spawn. And inside the spawn there is a set. You see, there is a set. And this set is gonna write, it's gonna change the data from moves and position. And GraphQL is gonna be listening to this because inside this set they have events to emit something. To publish some data. So we're gonna see them, but we have to execute this command. So let's go back to our terminal. Let's do it here. You see, I'm using all of these terminals. It's also execute, and then we have to pass this one. Remember, it's actions address. So execute, and then our function is spawn, and this is like now we can input the constructor. I mean the input parameters, but spawn has do not require any input parameters, so that's fine. Just spawn. Okay, this is a transaction hash. One more block has been produced. More events has been emitted. Yeah, in here. And let's see what happened in our GraphQL. Oh, you see, we get this data just now because we execute the spawn function. Entity updated. This is the ID. This is the key. This is the event ID. Yeah, because this is the event ID. It's different from this one. There are two events because one of them is for move and the other one is for position. We just have created the entities for moves and position. Great. Like they say, you're gonna get this data on your GraphQL. Yeah, that's cool. And yeah, that's it. In the GraphQL ID, by clicking docs, yeah, here we have more options. We can check. We have all of these like built-in queries. You can play around with this. So some subscriptions, they're going to be useful to connect with your client. The software we provide. Yeah, it's going to be. This has been a basic example now, so it's up to you. Try it again to check more. To talk a bit more entities. Test. Yeah, we can check the test. I think they are going to be useful here. Let's check the test first. Yeah, we have tests. We have tested the models because the models implement here these two. In this trade, they implement these two functions. Zero is equal. So we have to test these two functions. For example, they test this one. If we call this is zero, we have to get the true value. Yeah, this has to return a true because in this case x and y they are the same, so the assert can pass. So for is equal same, we have to pass. We have to create a new value, a new structure. Like yeah, this is the same. This is a new structure, and we're gonna compare this structure with position that is one since they are the same, so it should be equal. That's why we can run now so yes. Okay, this pass equal pass, back zero pass. So there is one more test move. So let's check here test move. So yeah, this time we have to import our models here. This is our models. This is also for like our models, but deploy it. Yeah, so you can see here when we start the test. Here, for example, we can set up the contract address like this. It's really useful. We just set up. We just pass some value here, and we say, okay, this is the constant contract address with this value. And this is going to be the color because we are doing the testing for testing purpose. Then remember, this time we have to pass array of models, yeah, position and moves right here. Maybe you can see we have to pass models array of models. We have the class hash here. So here we have to pass the class hash. Remember, for position, this one. For moves, we call this the class hash. So we got the models, and now we have the models. We can spawn our test word. This is also a util function from the Dojo core. So we pass the models and then we get the word with all the models inside. So after that, we can deploy our contract. Yeah, remember we have to pass the salt. In this case, it's the salt like this. Add actions. Remember also action, import action here actions. Cool. Action is the name of our module. Yeah, that's it. It's the name of our module, of our system. Okay. So action, we have to pass again the class hash. We have to format it. We pass these two, and then we can deploy our work. We get our contract address. Deploy system contract, and we get our contract system contract address, and then with here we get our dispatcher action system. So now we have the system, the action system. We can call it spawn. Spawn is like this is almost the same like we did also execute uh, actions contract address and spawn. So yeah, this is like this. And then also we can pass like a move. After we spawn, we can make a move. In this case, we're gonna pass the right. So it means they are gonna move to the right directions. After that, we're gonna, the system is gonna get updated so we can get the move data from the caller. So we get the move, then we're gonna create this variable. This is gonna be a direction type. It's gonna be to the right side, but we're gonna format it into file 252. How do we get this? Because we have this our utils. No, must be here. Yeah, here we implement our into. If it is right, it's gonna be number two. So we are doing this implementation convert from direction into file 252. That's why it can work here. So this is like the number two. Now we're gonna check the moves. Moves remaining is gonna be 99. Why? Because every time we move somewhere, our remaining is gonna be it's gonna decrease one number, so it's 99. This is according to our logic game. We define it this here earlier, so it's minus one, so this should be 99 because the init value was 100. After this, we're gonna check in our moves last direction into is gonna be this value 2. Yeah, right. If it is the if last direction is right, so we have to assert like this. This is for moves. Now we can check also position. For position, we have to call we're gonna get the value first, position, which is then the new position. And remember, if we move to the right side, X is gonna increase one. This is if we move to the right, X is gonna increase one. Yeah, this is our game logic. And Y should remain the same. And that's it. That's why when we do social test, it passed because everything is working fine. Let's try to move here as well. We can call this also execute. In this case, we're gonna call move. Let's call it like right. Yeah, right should be like number two. Let's call it like this. I have to pass like call data here. Call data to. Okay, yeah. In this case, if you want to pass the input parameter to your function, because for move you have to pass an input parameter. Move, we have to pass the direction. So in this case, I have to make like this call data and then all the input parameters. In case you need to pass two parameters, you have to pass at least two, eight, something like this. In this case, if I do that, I got this error because input too long. Yeah, because my function expect only one value, not two. So yeah, that's why if I pass 10, it's also error because I have to pass from 0 to 4. Yeah, I have defined it here from 0 to 4. So that's why if I input 10, they don't know how to handle this. That's why. So in case you want to debug your program, yeah, that's why I Campus 4, and it's still gonna work. Yeah, that's good. So I first input 2, it's moving to the right. If I input 4, it's moving where? Down. So yeah, that's it. Remember my playground? Oh yeah. My subscription is still working. Minutes ago I received this, but just now I got new data because I am interacting with the game. So it's keep updating here. At the same time, it's keep updating here and here. That's it. On these days, we are still on December. There is a hackathon for Dojo. Maybe you know Dojo Jam. So it's gonna be nice if you guys can join them and try to build something. And yeah, there are more. There are a lot of. There are more tool chains here to check out. There is also a slot. Slot is gonna help you also to spin up your developing, spinning up Katana and Tori instances. So yeah, you can check them. You can use them. There is a tutorial here how to use using slot, and yeah, you can get your URL. I'm gonna leave this like a homework. So you have to show your deployments with a slot. For example, yeah, your deployment with Katana, which is yeah, your deployment name with Katana should be the same as your GitHub user. And your deployment name with Tori is this one. Yeah, with Tori. Yeah, that's it. I think that's all for this lesson. Just try to check the book and find something interesting here. Okay, see you next time.